Hey guys, this video is to show you some of the common mistakes that were made in the result section revisions. So I'm just going to kind of go through this example one I sort of wrote up for you. First of all, I did in Google Word or whatever, Google Docs instead of Word. I want you to do it in Word, but this was just easiest for those of you who don't have it at home. So right off the bat, you really only need a section header with like your last name. Each section of a paper gets a section header except the introduction, so I just pretended we wrote a whole paper on M&Ms. Wouldn't that be terrible? An M&M result section. So that goes here. The written section always goes first in any of these, so I know that a lot of you did that backwards, but typically you put tables and graphs after the section that talks about them because the idea is someone will read what you've written first and then reference a graph. You are going to be talking about the data. You're going to describe the data in words and then reference the images and tables that support that. So a lot of you say some version of as the graph shows or as can be seen clearly in the graph. Try to leave words like clearly seen out. Just state what they should see and then reference it. So in here, don't say as the graph shows. You'd say something like on average, the largest number of M&Ms were found in the plain snack packs, and then peanut. And at the end of this, right here, I reference figure 1, which, by the way, is down here. So you can direct them where they can see the trend. I also want to point out a couple other things. I actually included the numbers. So largest number of M&Ms were found in the plain snack packs at 16, compared to peanut with an average of 7. I put the actual numbers in. You want people to look at your data if they need to, but the key points, including the numbers, actually need to be included in the results section itself. All right, let's talk for a second about this number after it. This is 16 plus or minus 1.03. That's actually our standard error. Typically in science, whenever you give an average, you also give the standard error right there with this plus or minus symbol. The way you get the plus or minus symbol on a Mac is just to do Shift, Option, and the plus button all at the same time. You'll get the plus or minus button. Shift, Option, plus on a Mac. So you can get, and if you need to, you just get that out of your table. You can cut and paste that number in there. So when you continue to talk about, remember, you really only need a paragraph, maybe 2 at most for this. You can talk about the highs, which pack had the highest number, which pack had the lowest number. You can talk about which had the highest average, which had the lowest average, which ones had the most variability, things of that nature. So and when you talk about that, you want to include the number, and at the end of the sentence, reference back to where they can see that. If you're going to talk raw data, you would then reference table 1, or depending on what order you put table 2. Then I also made a table for my t-test. So I have table 1 and table 2. Most of you should probably have something along that lines too. Towards the end of this section, you will talk about your inferential statistics. The wording for this is fairly standard. So you might say something along, I think what I wrote here was, it was expected that there would be a larger number of yellow M&Ms in the peanut packs compared to the plain packs. That was the hypothesis that we said we were all going to test. And then I went on to say, to test this, a t-test was used and referenced table 2 where you can see the results. For yellow plain versus peanut, there was a significant, I left out the word difference. I gave the p-value 0.03. Again, that's in your Excel sheet. But this finding actually supported the alternate hypothesis. Remember, the hypothesis we all agreed on was that there would be more yellow M&Ms in peanut and plain. That's not true. So we did reject our null hypothesis, and we supported the alternate. You can also go on and talk about the results of the t-test for the other colors. So let's talk about how to set up a table for a second. Most of you just cut and pasted this big ugly table. Where is it in Excel? Most of you just cut and pasted this big ugly table. So you have to remember, Excel is good for telling you if your statistics or what your numbers are and things like that, but it's the default table is a working thing. You have to make it into a visual thing. So what I did was I remade the table over here, so it's more user friendly. I put plain and peanut next to each other since that's what we're comparing, things of that nature. I also want to draw your attention to how I set up the numbers. So the way that I did this was, you don't need all these. If you scroll back over here, some of these have decimal places out 17 points. These aren't meaningful numbers. You didn't count tenths of an M&M, let alone millionths of an M&M. That's just like stuff that appears in your calculator. In science, we statistically, that's not correct. In science, we typically only use 2 decimal places. You should actually do the rules for significant figures, but I think if I made you do that right now, you would die. So I won't make you do that. But you should, on average, just use 2 decimal places. So to change that, I'll show you real quick here on Excel. Here's our p-value. You don't need to the millionth place on p-value. So I highlight this. I go up to Format and then Cells. The default on most Excel, if you change it to number, is already 2, but you can change it here. You can make it 1, you can make it 2, you can make it 3, whatever you want. Click OK, and my p-values will all change over to what I want them to be. To bring the table actually into Excel, because I don't like the way, I like this better set up like this, I just did Control Copy, go back to whatever I'm working in. I'm actually going to delete this one. Hi. Control V. And now I only have 2 decimal places, which is just much easier to read. People don't have to try to navigate the zeros. Keep in mind, tables get a caption above. They're numbered, table 1, whatever, table 2, and they get a caption above. Same thing with this one. Put in lines where you need them to make it readable. I put it between, and then I centered everything. It just made it easier to read. You don't have to use colored bars. I did that for make it easier for myself. I brought in my graph as a picture. If you just cut and paste it, sometimes the formatting gets wonky. For here, the charts are graphs, and you should refer to them as graphs, by the way, all the time. Get called a figure, whether it's a picture of an animal or a picture of a graph. It all gets called figure. Figure 1. Bar graph of average number of each color of M&Ms. Solid colors represent plain. Striped equals peanut. Error bars are standard error, and asterisks indicate significance via t-test. You need to tell people everything that appears on your graph so that they would understand it without reading. And this is about all it needs. Notice I only wrote a paragraph of written, and everything else is just tables and graphs. I'm going to push everything back a couple days because I think you guys need to revise this, and then you can go on and do the formatting for your own hypotheses, because you have to do one of these for your actual little individual study. I'm going to stop the video there, and you can ask me any questions in class.